Okay, so here is H8. All right, so the directions. Oh, actually, before I even get to that, we got to complete Susan's table. All right, now I have this blank. I'm going to fill it in with you because we at some point we need to practice filling this in over and over again because we need to have this memorized. Okay, so this is the full Susan's table. It has 3 columns, F, F prime, F double prime, and then below that 6 rows. 1, 2, 3, 4, 5, yeah. Okay, and the way you fill it in is like this, okay? You fill it in like this. F, increasing, decreasing, extrema. All right, and then you keep going. Concave up, concave down, point of inflection. All right, increasing, decreasing, extrema, concave up, concave down, point of inflection. Now, what we have so far, we have the first 3 rows, we have this so far, okay? So let's fill that in. If F is increasing, F prime is positive. F decreasing, F prime negative. Extrema on F, we're looking for a sign change on F prime. That's where F prime would cross the x-axis. That would be a sign change. Now, concave up. So, let me think. Oh, yeah. Okay. So, concave up. Guys, if F is concave up, you kind of saw before, if you were, following the video carefully, F is going to be concave up when F prime is increasing, okay? So F will be concave up. Do I have stuff from before? Okay, this is from before. So concave up, so remember, F prime is the slope of the tangent line. So right now it's super negative. It's getting less negative, less negative, less negative, 0, positive, more positive, more positive, more positive. So if the original graph is concave up, then the slope of the tangent line as you go along the graph is increasing. So F prime is increasing. On the other hand, if the graph is concave down, slope of the tangent line, so here's the tangent line, think of its slope, pretty positive, less positive, less positive, hits 0, negative, 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 more negative. Okay, so F is concave up, F prime is increased. When F prime is increasing, F is concave down when F prime is decreasing. Now guys, remember, a point of inflection is where F changes from concave up to concave down. Now think about this. If F is changing from concave up to concave down, that means that F prime is changing from increasing to decreasing. Well, if F prime is changing from increasing to decreasing, all right, so F prime is changing from increasing to decreasing. Right, so this is the graph of F prime. It's changing from increasing to decreasing. Well, then this point here on F prime would correspond to the point of inflection on F. And guys, what do you call this type of point? Look at this here. That's an extrema. That is an extrema. And the same thing would go for if F went from concave down to concave up. So F prime would go from decreasing to increasing. Okay, and this point at which F prime changed from decreasing to increasing, this would correspond to the point at which F changed from concave down to concave up. So that'd be, yeah, so the point of inflection on F corresponds to the extrema on F prime. And guys, I want you to notice this. Increasing, decreasing, extrema, increasing, decreasing, extrema. So this like repeats itself. And remember, F double prime, that's just the derivative of this. That's the derivative of F prime. So now, if you think of f prime as the original and f double prime as the derivative, well, then this increasing, decreasing extrema part just repeats itself. Positive, negative, sign change. There is a lot of information in these last 3 rows here, okay? So if f double prime is positive, that tells you that f prime is increasing, but it also tells you that f, the original, is concave up, okay? So there's a lot of information here, and we're about to use it. Okay, so I know that was a lot of explanation, guys, but it's just necessary. Okay, so we're going to use this in a moment to do these problems. So you are given the graph of f or f prime. Use the graph and Susan's table, when appropriate, to make determinations about f and f prime. Use Susan's table to explain your determinations when asked. Any inflection points on the graph of f are labeled with their coordinates. So if you look at f, this is f, right? Sometimes you're going to be looking at f prime, but this is f. So you might say, oh, it looks like there's an inflection point here. If it looks like there's an inflection point, I'm going to give it to you. Okay, so 8, 1, it looks like an inflection point. Therefore, it is because I labeled it. It is because I labeled it. That's why it's an inflection point. Okay. I'm making 4 of these. It's been a long day. All right, so part A. Oh, let's just look. All right, so here's F. I see that F has an extrema up here, okay? And an extrema on F is going to correspond to a sign change on F prime. Okay, so that's something that we know. It tells us nothing about F double prime. There's actually no information about F double prime for those first 3 rows. This A1 is a point of inflection. This is the graph of F. So a point of inflection on the graph of F, that's going to indicate an extrema on F prime. It's also going to indicate a sign change on F double prime. Okay, so right off the bat, those are some things that I see. Now let's read. At which value or values does F have a point of inflection? Oh, that's actually easy. It's labeled. So for part A, at x equals 8. Because they're asking for at which value. When they're asking at which value, that the answer is an x coordinate or an input. On which intervals is f concave down? Okay, well, you know that the graph is going to change concavity at an inflection point. Okay, so the question is f concave down, you know, before this inflection point or after? Okay, well, after it's curving up, so that's concave up. So the concave down is happening like here. So, and I should actually be moving along the graph from left to right. Curving down. Okay, so for part B, the answer is negative infinity up to 8. Now for part C, on which interval or intervals is f prime decreasing? Now here is the thing. You're looking at the graph of f. So when you explain, since you're looking at the graph of f, when you go to explain, your explanation needs to refer to the graph of f. All right? But we're looking for something, we're being asked something about f prime. On which interval or intervals is f prime decreasing? So f prime, we're asking where f prime is decreasing, and we're given the graph of f. So f prime decreasing, you really got to get used to using this table. F prime decreasing corresponds to f being concave down. So on the same interval that f is concave down, f prime is going to be decreasing. So part C, so it's actually the same as that, but they're asking why. Because, I'll say, because f is, we could just say CD, is concave down on this interval. On a test, though, especially the AP test, don't say CD, say concave down. Yeah, so you just got to use the table. All right, now this time we're looking at the graph of f prime. So any explanation, like if you look here, explain, any explanation has to refer back to what you are given. So we're given the graph of f prime. So these explanations are going to need to say because f prime and then something. This was the graph of f, so any explanation needed to be because f. All right, so any explanation is going to have to talk about f prime. So at which value or values does f prime have a local extrema? This is f prime, okay? This is f prime, so I'm looking at it. So x equals 4. That's where we've got a local extrema. At which value or values does f have a point of inflection? All right, this is not the graph of f. This is the graph of f prime, so I've got to go to my table because they're asking about f. So f is going to have a point of inflection when f prime, which we're looking at, has extrema. Okay, so part B, at which value or values does f have a point of inflection? X equals 4. Explain, because f prime has an extrema there. Okay, C, on which interval or intervals is f prime increasing? Okay, f prime increasing. Guys, this is f prime. So you're looking at it. You can just see with your eyes where it is increasing. It is increasing from -infinity up to 4. Okay, we don't have to explain why. It's right in front of us. That is f prime. Now this one will require an explanation. On which interval or intervals is f concave up? Explain. This is f prime. We want to know something about f. So you look at your Susan's table. F concave up. So f concave up when f prime is increasing. So since this is the graph of f prime, you're asking yourself, when is f prime increasing? And actually, we just answered that in part C. Okay. Explain why. Because f prime is increasing on that interval. Okay,